Testing, testing, testing. Hi there guys, my name is Rohan Beve and in today's video we are going to be talking about what if we could teleport. In today's video we are going to be talking about what would happen and what if we could teleport, okay? So let's say one day, or let's imagine, what if you could get to point A to point B instantly without moving a single bit, without worrying about traffic and other stuff, okay? What if you could just teleport, okay? Now, again, this might sound like fiction, as most people might say, but a type of physics known as quantum physics says it's actually possible for teleportation to happen. So let's first look at what science would show us if we could teleport. And one major problem, like again, for example, if we're doing the standard route of going to A to B, one major problem would be the Earth itself. You see, the Earth is orbiting around the sun, and the sun is moving through the galaxy at tremendous speeds, okay? Which means we are going at 1,000 kilometers per hour, okay? We won't feel any of that, okay? Because everything, the air, the atmosphere, the entire Earth is also moving at that same speed, okay? So let's say if we teleport and it failed to, keep this motion, okay? If it fails to preserve that motion, some stuff can happen, okay? What that means is that we could exit out, yes, but we could be at a different velocity. So we could maybe, instead of going fast, you might teleport and you'd be slow. Or in the worst and extreme cases, you could literally slam down anywhere at extreme speeds, which would mean that teleporting would have to have navigational accuracy, very good navigational accuracy, and computed power, okay, just to get to there. But this is again all more or less what if fiction, okay? But let's look at a type of physics that actually allows teleportation, okay? Quantum teleportation. Okay, let's say we have an apple, okay? And let's go to the molecular level. Let's go to the atoms of that apple, okay? And you see atoms contain information. Information, basically, what information is, it basically contains, it speaks about its position, energy, motion, and other quantum properties, okay? All of this is known as the atom's quantum state, okay? So, theoretically, we could technically take that quantum state and move it to another position, okay? So we could take the apple's quantum state and move it to the other area we want to go. So the quantum state is in A, then theoretically we can move it to B, okay? Now, and again, it is possible, okay? It can move from A to B, but the original copy, okay, A, would have to be destroyed, okay? But why does that have to happen? Well, it's due to a principle called the uncertainty principle, okay? It basically states that if we, try to research or do anything with an atom or something like that, you'll inevitably disturb it, okay? Which basically means we can't just scan and copy and paste that for teleportation. That's not possible. But scientists use a phenomenon called quantum entanglement. Okay, now scientists haven't figured out why this phenomenon happens, but what it basically means, let's say we have two electrons, okay, and they're entangled, okay? If they're entangled, okay, that basically means that both of them will have the same property, even at far distances, which technically means you can put information into one, and on the other side, the information would pop out, okay? And this is more or less how we could teleport. Now it has been actually done, okay? Scientists have already been able to teleport tiny particles, okay? But us, apples, and us itself have a bunch of molecules and stuff, and we're more complex. But hey, maybe the future could hold more. And that's basically it. And that's what if we could teleport. And that's basically it, okay? Thank you for watching this video, and hope to see you next time. Bye-bye.